Welcome back, Mr. Zalevich here for our screencast on translations. As we do when we begin each section, we're going to go to our Edmodo website and log in, entering our username and our password. And it'll take us to our home page, and we want to open up the group Transformations 5 and take a look at our post page. And at the end of our section today, we will take the translations quiz, and we'll get to that. Of course, we want to go to our folders and go to folder number 3, translations. And you'll see right off the bat there the translation screencast, which we are currently listening to, and quite a few other folders that we're going to explore. So let's talk about translations in general. These translations are slides on the graph. We translate points, segments, or images, and when we translate pictures, we translate all the points on the graph, the same number of units, either up, down, left, or right. One of the key things about translations is that the shape and size of the image does not change. Neither does the orientation or the direction that the shape appears in. For instance, if you were translating a triangle and the 14-degree angle was at the bottom of the triangle, after you translated that image, that 14-degree angle would still be at the bottom of the triangle. As far as utilizing our resources, we're going to look first at the notes. So we'll go back to our Edmodo file, and our notes are listed in Math is Fun. In geometry, translation simply means moving without rotating, resizing, or anything else, just moving. So we're just moving the picture on the graph. They talk about translating a shape. Everything moves in the same distance and the same direction. If you look at these translated points, they've all been translated in the same direction and the same distance. Here it looks like they've all been moved 1, 2, 3, 4 units up and 1, 2, 3, 4 units over. They do have a little translations gizmo included here, but we're not going to look at that. Writing it down is the key component. These are what you call image formulas, and oftentimes instead of saying translate this unit 30 units to the right and 40 units up, they will talk about it in terms of a graphing image formula. And to say the shape gets moved 30 units to the right is in the x direction, and 40 units up would be in the y direction. So we consider that x plus 30 and y plus 40 are the effects on the original coordinates. If the points move to the left or down, those formulas will be represented by negative signs instead of plus signs. And Math is Fun always has a nice quiz that you can take a look at and practice. We'll take a look at one question here. It says the rectangle slides to a new position. Which of the following could be a new position of the rectangle? So the key is we're performing a translation, and in a translation we talked about option A. It appears as if the picture turns. Option B certainly looks like it could be a translation as the entire image moved, a few units to the left and a few units down. Option C also appears to be a turn, as does option D. So these pictures, you can see how this is what we were talking about when we say orientation of the picture has changed. So I think our best answer here would be option B, and you'd be able to get an explanation and then of course move on to the next question. Helpful screenshots. Let's get back to our Edmodo page. And our first example is just a translated image. And as it's loaded up, it's a translation. They give the definition of translation here. It says in order to slide the figure, you move the figure a number of spaces in the direction indicated. And we'll take a look at the example. In the figure below, quadrilateral DEFG has been translated, and DEFG represented in blue here, 5 units to the left and 3 units down. This can be written as the effect on x and y becomes x translated, or x minus 5 translated to the left 5 units, and y minus 3 translated down 5 units. And the nice thing about the image formula is if they ask you a question without a graph, you can take those points. For instance, the coordinate of point D is 1, 2. You can take those points and plug them into the image formula. For instance, 1 minus 5 results in minus 4, and 2 we plug it into the y image formula, and 2 minus 3 results in minus 1. So the coordinates via the image formula of d prime are -4 and -1, and that's this point right here, and this is the image after it's been translated. Okay, so we could, use the paper and pencil method and translate it ourselves, 5 units to the left and 3 units down, or we can use the image formula. Our second example is a pair of translations, and it's just a single translation. They originally start with ABC, and they show the effects of ABC when translated down 5 units. This is the A prime, B prime, C prime that is indicated here with the coordinates. Once again, you could plug in 5 units down would be the equivalent of the image formula y minus 5. You could take the y coordinates, subtract 5 from them, and come up with the new y coordinates. And the same thing would be true of the second image, which is translated 6 units to the right. We could add 6 to all of the x coordinates and come up with our new x coordinates. And then finally the gizmo. The gizmos are unbelievably helpful and just do a great job of showing how the translations are represented. So you go to the Explore Learning site. We're going to launch the gizmo without logging in or going for the free trial. Once again, they do time you on the gizmo. And here we'll stop giving the free trial. So looking at our gizmo here is the figure type, and the options here are a point, segment, or a triangle. We're going to start by rotating a point. This will be our pre-image matrix, so our x and y coordinates. You can see how those change as I move the point around. Down here is going to be our translation, whether we're going to translate to the left or to the right, or we're going to translate down or up. Up here you will see our original point. I want to get that back on the point 0, 0. And the effect of the translation, and then finally our coordinates. And we'll use the ruler and the angle measure tool as we translate other figures. So, if we have a point here and we put it down at the point -10, or 10, a -10, and we want to translate it, let's say 5 units to the right and 3 units down, and J is the point after it's been translated. And you can see there, using the image formula, you add the x coordinate, x plus 5 to the 10 to get your new coordinate, J at 15 units to the right, and the original y coordinate of -10 was affected by a translation or a slide of 3 down, and the new coordinate is -13. So let's look at a translation of a segment, and the gizmo, of course, reset it here as close to 0 as we can. Say we have a segment up here at -10, +10, and we'll move this one over here, and we can go down here and translate this thing to the left and translate it up, and that has been moved. Every point on that line has been moved 7 units to the left and 6 units up. And then finally, the one that we refer to often in geometry, and I use in many of my section, is a translated triangle. That thing back on top of it, and you can drag this point wherever you want to. Drag point B out here. Now I have to translate a triangle size enough where it's going to move, and you'll be able to see the translation. Okay, so we're expecting all points A, B, and C of this triangle to move the same number of units, both left or right, and then the same number of units up and down. So let's move it to the left 7 and up 8, and you can see every point has been moved 7 to the left and 8 up. So our former point A is now J, our former point C is now L, and our former point B is now K. And like I said, the gizmos do a great job of showing the image formulas, allowing you to make all kinds of moves wherever you want to reflect that triangle, and they're just great tools to play with. You can click on the rulers, the pink ruler here. You can drag over to a side of our triangle, and it says it measures at length 15. You can measure the translated image, and you should notice that that side is congruent or equal, and it'll be true. Oops, I'm moving the point. I want to move the ruler. I move the segment AC and segment LJ also congruent. And I would expect the same to be true of segment AB and segment JK. Both measure at 18.3 units, and the angle measure tool does the same thing. We'll just take a look at it really quick. If I want to measure angle A or angle CAB, you can see the angle measure is 49.4 degrees. And if I measure angle J or angle LJK, I'm going to find out it's also 49.4 degrees. So a really cool tool to kind of help you understand translations thoroughly. Completing the objectives, we mastered our gizmo. If the 5 minutes isn't enough, like I said, registering for a free trial was quick and easy. And we have a reflections quiz, and I'll just show you where that is real quick, and you can take it. If you go back into the post section, that's where the quizzes show up. Go down to the reflections quiz and take the quiz. It's 5 questions, 10-minute time limit. Some true and false questions, and once you complete it, you are done with this section, and you've completed section 3. That's all I have for the translation section. Please post questions if you have any, and good luck.